Printed logos are everywhere. Brands are increasingly looking to find new ways to feature their insignia. A unique sign or high-quality branded item can help a company differentiate itself, and you, the CNC operator, can make that happen. No matter the CAD software you're using, no matter the CNC machine you own, the concepts and ideas in this video are going to help you land that next lucrative client. Or just make you an absolute hero with your friend who loves the New York Jets, and we both know that person needs something to be happy about. Let's increase your design understanding, have you flex your creative muscle, and give you a breakdown on exactly how to price your creations. Your logo to real life journey starts now. Whether you own a CNC machine for business or just for fun, at some point you will definitely be given a 2D logo as the basis for a build. When creating 2D logos, graphic artists can separate elements and direct the viewer's eye substantially through color and shading. Creating those 2D separations is just a matter of adding another shape, another overlay, another line, perhaps another bit of accenting text. Your 3D task is quite different. Today, I'm going to give you a contextual example of how to manage that conversion from 2D logo to 3D object. I know that as we go through this process, you're going to have thoughts on strategy and options. Add that to the conversation in the comments below. There are lots of ways to skin that CNC cat. A quick word about corporations. Corporations spend money in a way individuals do not. One business client is worth 20 individual clients. Yes, 20, because businesses have greater needs and greater resources. Building those corporate relationships by delivering quality builds is how you become the supplier of choice. Being the supplier of choice can do amazing things for your business. Be sure and put business networking on your agenda for this year. Your bottom line will thank you. Okay, this is the logo I was given, and this is my final build. The moment I get a logo, here are some of the factors my brain immediately begins balancing. Where are the interior edges of the elements? Is there a definite outer outline? Will this be a monochrome build or incorporate color? Will there be multiple pieces? How can I use depth? Would inlays or insets make sense? Would lights be a nice addition? And I'll tell you, 90% of the time, they are. How big is the object supposed to be? How does that size relate to the size of the machine? Is mounting required, or is this a standing build? What material makes sense? Are there multiple materials? What is the resolution of those materials? Where's the final build going? Indoors or outdoors? What finish will be required? And how much control is the client exercising? So many of those factors affect one another. It's a matrix of choices. As always, experience and experimentation are your best guides. You just have to start making some choices and moving forward. Sidebar. I've said on this channel before, if you want to build your business, give stuff away. Yeah, that's right. Give stuff away. Show people your capability. Put it on display. Give one to sell five. 60% of the time works every time, and that is the case here.
That doesn't make sense.
Last year, I made a large shark in cooperation with an artist. That's another video that might give you some ideas on how to make exceptional stuff, especially if you're struggling with drawing or inspiration. My friend saw that shark build and wanted a family logo done in a similar manner. He mentioned this to me offhand. I ran with it. And because of this build, I've already picked up another paying client. Think of builds you can give away that will promote your business. A person who loves what you made is your best advertising. All right, back to it. On this project, getting a logo was step one. Always ask for an SVG or DXF. Something with vector lines is best. Tracing and tweaking from a JPEG sucks. Oh, it's bad. You still face some editing choices with vector files, but that work is dramatically less when you start with real lines. So as always, we jump into the computer first. Looking at the logo, these are the questions my creative muscle started working on right away. What height for the islands? What depth of inset for those islands? What end mill would capture the details of the islands? How about a grain direction for them? 3D topographic carvings? If only time were infinite. How about contrasting material? Walnut, maple, they always win. What about all these separate elements at the top end of the design? Do I make separate pieces? Do I build this as a single part? How large will the overall build be? What pocketing depths will bring out different features? Should I chamfer the inner and outer portions of the design? These and so many more things are swimming through my head. Upon import and resizing, it was apparent this hash-marked edge around the design was a challenge. Since this was to be hung on a wall, the ragged edge the original design would produce was not going to work. The first thing I created was an offset path equal to the thickness of those hash marks. By first taking a measurement of the hash mark width, then creating an offset path equal to that number, I created a more complete looking outline. But that wasn't enough to make it cut ready. If I cut that outline and pocketed the hash marks, I would still have a sharp, irregular edge. So I created a second outline on each side in order to capture those hash marks as pockets. But what size offset would make a good looking edge? This is where a pair of calipers comes in handy. Visually, what looks like the right amount? What looks strong enough? What looks robust enough without interfering with the design structure or integrity of the logo? Having the visual representation in front of you while you design goes a long way to helping you make better design choices the first time. I ended up selecting an offset value of 3.5 millimeters from each side, this combined with the existing 5.5 millimeter hash mark pockets. I thought that outer border would look good, be strong enough to survive transport, and provide some mounting options. Experience and experimentation informed this decision-making process. Additionally, the use of simulation will give you insight into your part before you make it. Of course, design choices affect later design choices. These offset paths created a thorny little thing that had to be dealt with. When using an offset path, the corners are often not sharp lines. These corners end up being a collection of nodes to create a smooth change of direction. I wanted this outline to match the hash marks. This meant I had to get down in those nodes. Here's a quick look at me pulling the corners out to match the lines of the hash marks. It's not difficult, it just takes a little time. Sometimes you have to tweak the software's interpretation to fit your artistic goals. The machines cannot do everything, yet when they can... With the outline construction decided, it was on to another dicey issue surrounding those hash marks and offsets. The top of this J. In print, no problem. Make separate parts, have some overlap, some not. It doesn't really matter. In the real world, what to do. The offset paths we just created have caused this already confusing part of the design to be even more baffling. With uncertainty comes opportunity and more questions. Should I start separating the elements? Should I use tabs as links between those elements? How would that affect the overall look of the logo? I messed around with this for quite a while and decided that the logo's original shape needed to remain intact. I would tolerate the interior overlaps and set out to create a singular outline for the entire logo. This meant I would have to boolean the outer outlines of the smaller pieces and the larger bottom portion. I also decided the outer edge hash mark pockets needed to carry throughout the entire design, and some irregularity in those hash marks might actually look good. Creation of a singular outline did leave me with some cut-ins that I wasn't sure I liked, but my plan called for an MDF test before moving to a walnut panel that costs real money. By creating an MDF version, I could assess all of my design choices in that glue and sawdust before the glorious, beautiful, fancy walnut went under the lights of my Shapeoko 5 Pro. MDF testing is something you need to do on new projects. Be sure the material and time needed to create that piece are part of your bid. The client needs to pay for every step in the process. More on that when we get to pricing. In that discussion, you're either going to love it or be infuriated. Your choice. Now, how about these islands? Here's where the advantage of making something in the real world can be fun. Artists are always using shadows, outlines, and blurs to create depth. For you, the CNC operator, adding depth is easy. Whether that's a pocket or an inset piece, the use of multiple depths makes something come alive. In this case, I went with two pocketing strategies and some inset parts. My first decision was to pocket back the entire interior of the J. This would give some definition to the overall shape. Some woodworking knowledge came into play when deciding how much to cut in that main pocket. Experience and experimentation play their role once again. If you pocket away a ton of depth in something like walnut, you are releasing tension in that wood. So no matter how much care you took flattening the walnut panel, if you remove too much material, that board will substantially warp and twist. Ask me how I know. Here, a main pocket cut-in of 3.5 millimeters should be small enough relative to the 18.4 millimeter overall thickness. That's 0.72 in imperial, which by the way is substantially harder to grasp in smaller increments. You can keep your thous and weirdo fractions. Regardless of how you define it, this should give enough definition to the area without risking massive shape changes. Into that large pocketed area, I placed the cut-ins for the islands. That's pockets in pockets. Now, you could just cut the island pockets and have that be the design, but I think it's much cooler to have them rise out of the main body just as they rise out of the Pacific Ocean. I cut the MDF islands at a full 3/4 inch depth and mounted them into 2 millimeter deep pockets. Oh no, not mixed measurements! That ended up not quite being what I wanted. Later in the final version, I faced off the area for the islands by 6mm. This made them 6mm thinner or shorter in the design, and I mounted them in 3mm deep insets for a little extra overlap when glued into place. An important note here, you want to cut your pockets and inset pieces with the same end mill. That way the irregular details of the edges match. Your pockets may end up with slightly more detail, but don't worry, if you miss it in simulation, a chisel or knife can make quick work of that. If you do catch it on the computer, it's back to node editing for the win. When I ran the MDF test, delightfully it appeared that I had nailed most of the big design choices. The only changes would be the dimensions of the islands and some minor node adjustments. And as always, adjustments to the cutting paths to optimize the project. You always learn more by running something than by just looking at it on the computer. Know this, I, like you, am often trying to figure things out as the project develops. This is not the case of someone who just knows how to do everything. I get down in the weeds, or in this case, the nodes, and have to figure it out. Ah, that would be a great CNC t-shirt, wouldn't it? Down in the nodes. Success in MDF meant it was time to select the wood and glue up a panel. In walnut and many other woods, there's grain structure to consider as you build your stock. Selecting boards that will blend together is an art in itself. In most cases, going to the expense of purchasing book match pieces or using a long single board of walnut is unnecessary. Hit up the short section, make color and grain selections to your liking, do quality work with the joinery and glue up, and enjoy how good walnut looks when you apply finish. The inconsistencies between different grains tend to disappear after machining and finishing. Wood selected, panel created, it was time to consider the look of the islands. In MDF, I can cut them from wherever on the panel there's no grain and no life to the wood. For the final item, I chose to move the islands onto one plank of my panel to keep their grain and color consistent. I also made sure not to rotate the islands from their established angle so the grain traveled the same way on each island. Okay, this is a small detail, but those types of choices add up over the course of a project. People don't know why something looks exceptional, they only know that it does. So it's worth remembering, materials matter. Put some punch in your builds by choosing top shelf materials. Quality materials cost 2x, but it means you can charge 4x. The beauty and durability matter when you're deciding what to charge for your creations. More soon when we talk about pricing. Now comes nervous time. I've taken all the time to test, to purchase, and create a panel. There's $130 in wood sitting there. I've flattened it on both sides. That's more machining time spent. And now it's either gonna work or I'm gonna mess something up and have to problem solve, or don't say it, start over. No! No! This machining montage will show you I got this one right. Roll that beautiful machining footage. Item machined, this leads me to pricing. Here's the finish being applied while we discuss just how much something like this should actually cost. Calculations go as follows. At a reasonable rate, your time is worth $50 to $70 an hour or more. Yes, perhaps more. You need to charge for time to get the material, $50 an hour. The material itself, mark it up 20 to 30%. MDF for testing, this could be passed through at cost or marked up, your choice. CAD time, $70 an hour. That's a learned skill you've got there. Woodworking to create the panel, again more expertise, $50 an hour. Machine time, minimum $50 an hour, more like $70. You're using up tools. So that's flattening, $70 an hour. Machining of the MDF version, $70 an hour. Machining of the walnut version, $70 an hour. Finishing work, $50 to $70 an hour or more. Packaging as needed, so add in materials and time charges for building the box for transport. Shipping as necessary, and then add 30% for profit. That's right, profit. You are not your own hourly employee. You are a business that must have profits for the owner, you. Here's my breakdown of this particular project, receipts and all. $1,500 all day. All day. And if you don't like that number, you might have the wrong clients. You might need new customers. The world is full of people willing to pay for quality work. Go find them. Stop messing around with Walmart shoppers. Don't tell me about where you live. Don't tell me about how much fun you're having. Either give it away or charge a real price. And remember, the main goal here on this channel, we want to teach you how to think and problem solve inside the CNC process so you have success. This means addressing many different aspects of the design, machining, and creation of CNC objects over the course of many videos. You're going to gather skills as you go. We want to build your toolbox of skills so your next creation exceeds your expectations. As you continue that progression, you'll find financial and emotional rewards. CNC has so much powerful potential, and we're glad you're here. So join us again for more information, ideas, and inspiration, and definitely leave your comments below. We will read them, and I know you have some pricing thoughts.